Okay, let us handle this one. It says a mass of 5 kilograms is pulled at a constant speed up a slope inclined at 20 degrees. So now, in our solution, I'm going to be having my slope inclined at 20 degrees. Horizontal. The angle of friction is 15 degrees. So here in degrees and now they are giving us number as 15 degrees. And a force pulling the mass up the slope is 30 newtons. So we have now there is a force that is pulling our mass. Remember, this weight of this mass is going to be 5G. But there is a force pulling it up the slope. So now, when we have that, what happens? Now, it's pulling it at, wait. Okay, so now we have a force that is pulling this up here, and then they're telling us that the 30 newtons, find the angle between the 5 newtons force and then the slope, meaning this is pushing it at, is pulling it at a certain angle. So remember, this one is going to be having a reaction. Now here, you can use Lami's theorem or use the method being used. Now let me use Lami's theorem. If I get this, I will also show you the other method. So here, remember, the force is pulling by a certain angle, which we don't know. So this force is pulling is 30 newtons at the angle which we are going to call alpha. Now, remember, always, because it's going downwards, it's pulling it, so our acceleration is going to be in this direction. So meaning frictional force is going to oppose. So we're going to be having a frictional force opposing it. So our frictional force is going to be this side. So you see that here I'm not resolving it. So I'm having my frictional force this side. Now, if we are going to use Lami's theorem, you don't need to resolve this, as we are going to see. So we have this force. Now, remember, the S we want, the resultant we want, because this is going to be our R. The resultant we have, the reaction we want, is always between this and that. So this is the resultant I want. So, which I'm going to call the T. Now they are giving me this angle, the angle of friction. Remember, it's the angle between the resultant and then the reaction. So they are giving it to me as 15 degrees there. So now they have to use Lami's theorem. The idea is very easy. You see, to use Lami's theorem, if this, remember, now I'm going to bring out that thing out as, if you want to use Lami's theorem, now we need to get this angle here. We need to get this angle here, and then we need to get that angle there. So if I pull it out like this, so when I pull it out, I'm going to be having my resultant R. It's going to be there. I have a force here, which is 30 newtons. I have an angle alpha. Then I have a weight, which is acting in this direction. I think you can see the weight is acting in this direction like this. So I have a weight which is 5 grams, 5G. So then I also have this reaction here, which is S. So maybe let me put the force properly. The weight, so that people don't take it as a straight line. Okay, so this is going to be my weight here. It's not straight, but it's going to be 5G. All we are looking for, remember, this force here, remember this angle here, remember this is 90, this angle here is 90, this is 90. So meaning this one is going to be 90 minus alpha. And then also this one here, this angle here, and then that's that this one is 15 degrees. And then remember, If that's 15, then this one, the balance is going to be 75. This one is going to be 75 degrees. Now, if that's 75 degrees, now we need to get this angle here, where the weight is active. First of all, we start, we have this one is already now known. You know this one is not 90, don't take it to be 90, because you see this plane like this one is active below it. Don't take it to be 90, it's not 90 degrees. I don't know if I don't know how I can explain that so that people don't take it to be 90 degrees. When we deliberate again, people may assume it's 90 degrees. It's not. Because it's not perpendicular to it. The weight is not perpendicular to the slope. Never. Okay, maybe if I'm to draw it like this, I think that will make more sense. Understand? Okay, so now the other idea is, I think we can see that we say this angle here, this result and there, is going to be having the same angle, so this is going to be 20 degrees also there. So meaning, this out and remember it's that line. So if I have this as 20 degrees, this is 20 degrees, it means that this one is going to be, if this is 20, now the balance here is going to be 70 degrees because that's 90. And so this one will be our 90. And so now, if we are to draw now that at once, this is what we are going to be adding. I'm going to have this force here, S. I'm going to have this force here, 30 newtons. And I have another one here, the weight, which is 5 G. Now let us add these angles. This angle here is going to be, when we add 15 to 90, we get 105, then minus alpha, which we are looking for. Then when we add the alpha, this alpha plus 90 plus this, now this will give us 90 plus this, will get 115, then plus alpha, this one we are adding, then this one here we are going to get 145 degrees. And so there, once we reach there, we use Lagrange's theorem. So what does Lagrange say there? It says that this, okay, it says that S over the angle opposite sine 110 plus alpha would be equal to this 5e over the sine of the angle opposite, which is 105 minus alpha, equaling to S over sine of the angle opposite, which is sine 110 plus alpha. And so from there, we can simply get that. So if I take now is pair, if I take this, I can also take that and that. It's up to you. So, sorry, I want to mix this one, 5G, this is 0.5 minus alpha, then S goes with this, yes, then 30, sorry, I've repeated S. This is supposed to be 30, equaling to 30 over the sine of the angle opposite, which is 145 degrees. So now, from there, I think we see that we can aggregate this, then this one here. So from there, if you cross multiply, that our 5e, then sine 145 will be equal to 30, sine 105 minus alpha. So I want this, so I can divide it by 30. So this side I have 5 into 9.8 sine 145 all over 30 equaling to, we can every expand this angle here. So this will be now let us expand this. It's going to be sine 105 cos alpha or plus, why am I doing this? Let me just get this and then I subtract. I don't know why I'm getting to do these things. So let me just get this. Where am I expanding yet? This is just this. Let me get this and then I get the inverse there. So all of this is going to give us sine 145 divided by 30. So sine 105 minus alpha is giving me 0.9368. So meaning my 105 minus alpha, it will give me sine inverse of this 9368. It is giving me 69.51 degrees. So from there, so my alpha is going to be 1. We take this side and bring this side, minus 69.51, which gives me that 5.49 degrees. So we have now this angle, and then if we come here, we can also get our S. How are we going to get our S? We have our S there. This S here. So remember our S over my S here, my S there, over sine of 110 plus that 5.49 is equaling to 30 over sine 145. So that our S, we shall cross multiply 30 sine of 145.49 over sine 451. Yup. And so our S, that resultant force, is going to be that's here is 29.632 newtons, and so that's going to be our resultant. Now, if you want the other way around, you can use the idea of resolving, but that one is going to be a bit lengthy compared to this one when you use line unit theory. So that's it, members. I wish you well.